just what it sounds like. It's nitrogen gas that's been cooled enough to become a liquid. And in order to become a liquid, nitrogen has to be extremely, extremely cold, way colder than this room, which is why we see all this gas coming out of the liquid, boiling into the air. So what will happen is, since the liquid is so cold, it'll really quickly cool anything that it touches. So here I have some liquid corn syrup. And as we know, liquids have volume but no certain shape. So I'm able to squeeze the corn syrup out of the bottle as a flowing liquid into the nitrogen. But what happens is that it cools so fast in that nitrogen that it immediately turns into a solid. And when it does that, it's going to take on whatever shape it was in when it hit the nitrogen. So I've got like a yarn ball looking thing here. Have some longer strings. And if we had just let the corn syrup cool slowly, being a liquid, it would just have sort of spread out into a pool and frozen solid that way. Instead, it froze in whatever temporary state it was in as a liquid. It happened that quickly. So that's what happens when we have a liquid and we super freeze it using liquid nitrogen. What about something that started out already being a solid? Something like a gummy bear. Where did the gummy bears go? Are we out? Here, I'll use the Play-Doh. Or something like Play-Doh. So I can form my Play-Doh into whatever shape I want. Since it's a solid, it'll keep that shape if I just set it down somewhere. Okay. So will all of these gummy bears. So what's going to happen to them when I put them in liquid nitrogen? Since they can't freeze, they're already solid, they can't freeze into a solid. What's going to happen to these guys is that they are going to super freeze, and it's going to make them really, really brittle. So if you think about a gummy bear or a piece of Play-Doh, it's a solid, but you can still sort of squish it. You can maybe change its shape a little bit, and it won't hurt the substance. Once it's been extra cold, though, in this liquid nitrogen, I can take a gummy bear out of the liquid nitrogen, and when I set it down, first I'm going to notice that I can't really just push on it and squeeze it the way I could before I froze it. And actually, if I take a hammer, we're going to see if it was just a regular gummy bear, not super frozen, I would hit it with a hammer and it would probably just go splat. But this one, if I hit it with a hammer, it shatters into a million little pieces because it's gotten that brittle. Pretty much the same thing happened to my Play-Doh. And this one I can tell something different happened. It's a little bit different shade of pink than it was. And when I hit this with a hammer, again, it breaks up into a bunch of pieces. So we can see that the Play-Doh and the gummy bears made sort of different size pieces. And that tells me just how brittle each one was. The gummy bear that broke into more pieces became more brittle, so it was more susceptible to that super cooling liquid nitrogen situation. Right? Then we'll do one more gummy bear just because it's really a lot of fun.